So the next one we're gonna look at, again, picking up on that 10.1, 10.2 notes, is a fraction to a power. And we're also gonna do like a product to a power as well in this. Well, we've already done some of them. We've done like two-thirds squared. And so that means we're squaring both of these. We're doing 2/3 times itself, 2/3, which is 2 times 2 is 4, 3 times 3, which is 9. And that's correct on your paper. So then I have, that's the same thing as 2 squared, 3 squared. So we said you could really just square each one. That's gonna be the same, like if I have 1/5 cubed, that means I'm doing 1/5 times itself 3 times. And so 1 times 1 times 1 is 1. 5 times 5 is 25 times 5 is 125. And that would be the same thing as if I just cubed 1 and I cubed 5. That's a little 3. And so that would give me 1 cubed is 1 and 5 cubed is 125. Okay, and 2 squared is 4, 3 squared is 9. Okay, so these are two different ways to find the same thing. I can apply that same property when I'm squaring multiple numbers in parentheses. So instead of doing like 3 times 2 is 6 and then squaring it, I could also say, okay, means 3 times 2 times itself 3 times 3, which is the same thing if I use commutative property and shift things around, change the order. That's the same thing as 3 times 3, which is 3 squared, and 2 times 2, which is 2 squared. And so an easier way to write this is just I'm squaring both of these things in the parentheses. 3 squared and then 2 squared. I can only do that if there's a multiplication in between them. Okay, any other symbol, I mean, it works for multiplication or division, but if you're adding or subtracting, this does not work. Please keep that in mind. Okay, so this is the same thing. If I want to do 4 times 3 cubed, what it means is I'm multiplying 4 times 3 by itself 3 times. And if I want to rearrange this, I can do 4 times 4 times 4, like multiply the 4's together, and 3 times 3 times 3, which is the same thing as 4 cubed, 3 cubed. And so an easier way to do this is just I'm cubing the 4 and I'm cubing the 3. And this is useful also, like if you don't have a calculator, because 4 times 3 is 12, and then you would do 12 cubed, and I have no clue what 12 cubed is, but it's easier to find like 4 cubed and then 3 cubed, and then possibly multiply them together. Okay. But we're going to do more, again, variables. I wanted to show you with numbers because sometimes it makes more sense, but we're going to do the same thing with variables. So if I want to do x over y squared squared, I'm doing x over y squared times itself. Okay. And then remember we said if we multiply, we add, and there's an exponent of 1 if we don't write that. So x times x is x to the 1 plus 1, which is x squared. And y squared is y to the 2 plus 2. We added the exponents, which is y to the 4th. Okay, that's a 2 and a 2. It's hard to read. And so an easier way to do this, like a shortcut, is I could just square the x and I could square the y squared. So I square both of them. And x squared is just x squared. And then y squared, if I'm squaring that, this is the rule we just did in the last one. When I'm raising something to a power, we said we multiply the exponents. So I have x squared over y to the 4th. 2 times 2 is 4. And we can do that whether we're dividing or if we're multiplying. So this is the same thing. X squared y cubed, cubed really means x squared y cubed times x squared y cubed times x squared y cubed. Yeah, I don't really have enough room, so I'm going to come down here for it. So that would be x squared times x squared times x squared times y cubed times y cubed times y cubed. And then again, when we're multiplying with the same base, we said we add the exponent. So it'd be 2 plus 2 plus 2.
which is 4 plus 2, which is 6. And this is 3 plus 3 plus 3, which is 3 plus 3, which is 6, plus 3, which is 9. Okay. And again, that seems more complicated. An easier way is I can raise each one in the parentheses to that exponent. And then when I raise a power to a power, I multiply. Sorry, this should be a 3. So I would do x squared times 3 and y cubed times 3. And so I get x 2 times 3 is to the 6 and y 3 times 3, which is 9. Okay, so 2 different ways to do it. I think this way is definitely shorter and easier. But it says now determine a general rule when we raise a fraction to an exponent. So if I have like x over y to the m, we raise both x to the m and y to the m. Okay, and if I also have a product, x to the y to the m, I raise each one, x to the m, y to the m. And then just remember, if x or y have an exponent already, then we multiply the exponent. Okay, and so that's kind of the exponent to an exponent property